Alright, we're going to pick up from where we left off in our last video on nonlinear systems, solving them algebraically. So we finished example 8. We're going to pick up example 9. We're going to have the system y equals x squared minus 6x plus 10 and y equals negative 3 x squared minus 12x minus 5. And since they both equal y, I'm going to set them equal to each other. So x squared minus 6x plus 10 is equal to negative 3x squared minus 12x minus 5. We're going to get everything on one side. I'm going to move everything to the left. So I'm going to add 3x squared. I'm going to add 12x. And then I'm going to add 5. So on the right, we're going to be left with 0. On the left, x squared plus 3x squared is 4x squared. Negative 6x plus 12 is plus 6x. And 10 plus 5 is plus 15. This one I know I can't factor. So I'm going to use the quadratic equation, quadratic formula, to solve this. So I'm going to take and first identify my a, b, and c. A is always in front of x squared, b is in front of x, and c is our constant at the end. So, as a reminder, we take negative b, so in this case negative 6, we plus or minus the square root of b squared, so 6 squared, minus 4 times a, in this case it's 4, times c, which in this case is 15, and we divide all of that by 2 times a, in this case that's 4. We can combine everything. So we're going to have negative 6 plus the square root of, well, we're going to get 6 squared is 36. 4 times 15 is going to give us 240. 36 minus 240 is going to give us negative 204, and that's divided by 2 times 4 is 8. Now, I look at this, and I can automatically tell we're going to have an issue. Because if you remember back to our unit on complex numbers, the square root of a negative number means we can pull an I out. So negative 6 plus or minus I square root of 204. I don't even care if we can break 204 up. We have an imaginary solution here, which means we have no real solutions. We don't even have to continue. Because plugging those back in for x to figure out a y value, that's going to get really messy really fast. So we're just going to say no real solutions. We have one more example left, and then we're done with this discussion on nonlinear systems. So example 10, we're going to solve 9x squared plus 16y squared equals 289, and x squared minus y squared equals 21. Now in this case, every variable is squared. And there's a few different things we could do. We could multiply the entire second equation by 16 and use elimination, but I think it's going to be easier if we actually solve that equation for x squared, the second one, for x squared, and then we can substitute it in to the first equation. Because all we're going to do then is add y squared to both sides. So x squared will be 21 plus y squared, and now we can just plug that in to that first equation. So we're going to have 9 times 21 plus y squared plus 16y squared equals 289. Well, 9 times 21 is 189. If we distribute, 9 times y squared is plus 9y squared plus 16y squared equals 289. So let's combine our y squared terms. We're going to have 189 plus 25y squared equals 289. We can subtract 189 from both sides. We're going to get 25 y squared equals 100. If we now divide by 25, we're going to get y squared equals 4. Then we can take the square root of both sides. So y is going to equal plus or minus 2. So now we're going to take both positive 2 and negative 2, and I'm going to use that second equation to figure out some x values. So we're going to go x squared minus, we'll start with 2 squared equals 21, and I'm going to even just write the other equation while we're at it. X squared minus negative 2 squared equals 21. We'll solve these independently of each other. 2 squared is 4, so we've got x squared minus 4 equals 21. If we add 4, we're going to have x squared equals 25. Take the square root, we're going to get x equals plus or minus 5. So we've got 2 possible solutions now. We've got 2, 5, and we've got 2, negative 5. Let's see what we get when we put in negative 2. Negative 2 squared, oh, I made another error, guys. I need to switch my 2's and 5's in those ordered pairs before I can move on. So I'm going to have 5, 2, and I'm going to have negative 5, 2. There's my solutions, 2 of them. Now, negative 2 squared, that is 4. X squared minus 4 equals 21. I'm going to add 4. So x squared equals 25. If we take the square root, we're going to get x equals, again, plus or minus 5. Interesting. So we're going to have 2 more answers. 5, negative 2, and negative 5, negative 2. So we had 4 answers again. That is neat. And that's going to wrap up our lesson on nonlinear systems of equations.